everyone, and welcome to this AMA session with self-driving car lead David Silver. My name is Anaïs. I'm the community manager for Udacity in Europe. I'm really happy to be here with you tonight. I've already seen some great questions from you guys, so I can't wait to get to it. I'm going to tell you a little bit more about how this webinar is going to go. So first, I'm going to let David Silver introduce himself. He's also going to tell you a little bit more about what exactly is in the self-driving car program. After we've done that, we're going to go through a couple of the questions that you guys submitted in advance. And we really want to thank you because we saw some really great questions in there. So we've selected a few that David is going to answer. And after that, we will get to a live questions and answers. This means that all of you guys can post your questions in the live YouTube chat. So make sure you do that, and we'll select a couple of questions. We'll try to answer as many as possible. And yeah, we're really excited. So David, thank you so much for joining. You're actually joining us live from your hometown in Virginia. So special thanks. And if you're okay, I'm just going to let you introduce yourself briefly and then tell us a little bit more about what exactly is in the program of the Self-Driving Car Engineer Nano degree.
You are welcome. Thanks for the kind introduction. I am coming from my parents' house where I grew up in Vienna, Virginia, the world's #2 Vienna. Great place. Really happy to meet all of you. I am the team lead for the Udacity Self-Driving Car Engineer Nano degree program, and I want to take just a little bit of time and tell you all about what the program is like and the types of things that that we cover in the program and some of the cool projects that students have done in the program and that you would get to do if you wanted to join the program. So I'll flip over to a slide deck for a moment just to share with you what the program covers. I'm a little ahead of my slide deck. So it's pretty quick. I'll just go through what the program entails, and then we can dive into more specific questions. So the program is 9 months long, and it covers kind of the entire autonomous vehicle technology stack over the course of 9 months, each month on a different topic. And the 9 months are divided into 3 terms of 3 months each. So the very first term, which is what you would start in if you enrolled now, consists of an introduction, a month on deep learning, and a month on more standard computer vision techniques. So in the introductory month, we cover what self-driving cars are, how they work at a very high level, the different components and systems that comprise them. And then we dive into deep learning, which is a really new, exciting area of machine learning that involves using deep neural networks to train computers to perform tasks based on data. Some of you all might be very familiar with deep learning. It might be new to some of you all. Either way, we start from kind of the assumption that you're not necessarily familiar with deep learning. We take you through the basics of machine learning that you need to know in order to get to the point where you can build deep neural networks, and you can skip those basics if you're already very familiar with deep learning. And then we dive into convolutional neural networks, which is a type of neural network that's really good for image processing. We use that a lot for working with camera data in self-driving cars, and an even more advanced technique called end-to-end learning, which is basically where a computer learns to drive from watching a human drive. And I'll tell you a little bit more about what that project entails in a few slides. One of the really exciting things about the program is that we partner with industry, and you're learning directly from people who are working on this every day at different companies. So our deep learning content is built in collaboration with both NVIDIA, which is the world's leading graphical processing unit manufacturer. They're really, really big into using GPUs for accelerating deep learning. They're one of the most important companies in the world today for building deep neural networks. And also with Uber ATG, we partner very closely with their perception team, which uses deep learning very heavily. And so both of those companies help teach the techniques they use for working with deep neural networks. The third month of term 1 is more standard computer vision, which is still really important even in kind of the new era of deep learning. And so things like color spaces and camera physics and perspective transforms, and the projects in this module involve vehicle detection and advanced lane finding, and they're really visually rewarding. So that's term one. Term two dives more into hardcore robotics. And so these are things like sensor fusion, which is taking radar and LiDAR data and using it to fuse together, or using it to fuse together sensor data to figure out what the world looks like around us. So say we have a radar that tells us that a car is off to our left, and a laser that tells us that a car is also off to our left, but in a slightly different place. Sensor fusion is how we fuse that data together over time to get a picture of what the environment around us looks like. And we build that module with Mercedes-Benz. Actually, their North America Research and Development Office, MBR-DNA in Sunnyvale, California. But I assume many of you in Europe are very familiar with Daimler and Mercedes-Benz. They're one of the leaders in building self-driving cars in the world right now. We move on to the next month, which is localization. So in sensor fusion, we're figuring out what the world around us looks like. In localization, we're figuring out where we are in that world. And that might seem really easy. Nowadays, we all drive around with GPSs. We have a pretty good sense of where we are in the world. But it's actually the case that GPS is only accurate to within about 1 to 2 meters. And if you think about how big 1 to 2 meters is, we could be driving down the road, and if we're off by 1 to 2 meters, we could be, off driving on the sidewalk, hitting things, and that would be really bad. So for self-driving cars, what we need is localization to within single-digit centimeter level accuracy. And we teach techniques like particle filters and motion models to help us localize the vehicle to that level of accuracy, again, working with the localization team at Mercedes-Benz. The final month of term 2 is spent on control. Control is how we follow a trajectory. So if you think about making a turn through an intersection or going around a roundabout, it's pretty easy for me as a human driver at this point. I just kind of turn the wheel, and if I turn too hard, I ease up a little bit. And if I need to hit the gas, I hit the gas, or if I'm going too fast, maybe I hit the brakes. I kind of intuitively know how to do that, but teaching a car how to do that turns out to be really difficult. And so we have a number of different algorithms called controllers that control how the vehicle follows a trajectory that we want to follow by using the steering and throttle and brake commands. So that's term 2 of the program. Term 3 is path planning. Path planning, again, with Mercedes-Benz, is really the brains of the vehicle. This is how does the vehicle decide whether it should turn left or turn right, or go faster, go slower, merge one lane to the left. This is both kind of at the macro level, how do I get from my house to my office, and at the micro level, what should I do if a cat jumps out in front of me in the road? How do I react to that? And so we cover a number of different aspects of path planning, both predicting what we think the cars around us are going to do, and then deciding how we want to react to that world to get where we want to go. The second month of the final term, so the 8th month of the entire 9-month program, is an elective month. And this is where you can choose one area that you want to go really deep on. So the 2 electives that we're launching with, and then we'll build out more, those 2 electives are advanced deep learning. So now we're going to take the deep neural networks we learned about earlier on, and we're going to do even more sophisticated things like semantic segmentation. So basically coloring camera images based on what types of things we're seeing in the image. This is really helpful, for example, in identifying free space on the road. If we can color every pixel on the road in a camera image as being road or not road, then we get a much better sense of where is it that we're able to drive, and where are things like cars occupying space that we would otherwise want to move into. And we teach that with NVIDIA. With Electrobit, which is a terrific German automotive supplier, we are teaching functional safety. So this is the process of how do we design and develop safe vehicle systems. Everything from kind of analysis and documentation through some of the ways of practicing defensive coding. And then the final month of the program is kind of the most exciting. This is system integration, and this is where we pull together all of the different things that we've learned throughout the course: deep learning, computer vision, sensor fusion, localization, control, path planning, all of that together into a single vehicle system. and we put it on the actual Udacity self-driving car. So Udacity actually has a self-driving car in California, and as students reach this final month, we break them up into teams, and they work on a particular module for the Udacity self-driving car, and over the course of the final month, they'll get the opportunity to put their code on the car and see how it does, and we send them videos and log files showing how the car is performing with their code. And we think of that as like a really exciting kind of only at Udacity experience. It's not too many places in the world that you can go and actually put your own code on a self-driving car and get a sense how it works. And it's a great thing to be able to talk with employers about the difference between coding just kind of in the classroom and in real life on an actual vehicle. So that's the 9 months of the program. The last thing I wanted to leave you with are some student projects. I believe we'll be pasting a couple of YouTube links into the YouTube page that you're looking at now. A couple of student projects that are worth looking at. One is a student of ours named Annie Flippo. She created a really nice solution to our behavioral cloning project. That's the end-to-end learning, end-to-end deep neural network for self-driving cars project that I mentioned earlier. And what students do is they take the Udacity simulator, which is kind of like a video game where you can drive your simulated car around a track in the video game. And what happens is essentially the video game or the simulator saves your driving data. And you can use that driving data, basically camera images mapped to steering angles from how you drove the car yourself in the simulator. You can use that to train a deep neural network to drive just like you. And so if you train your deep neural network right, then you can get the car to drive autonomously using just your deep neural network instead of driving it manually yourself. Sorry for all these pop-ups here. I should figure out how to turn that off earlier. But if you click through to Annie's link, what you can see is the car driving in the simulator and then outputting camera images to the terminal, and the terminal's running those camera images through a deep neural network. The deep neural network is outputting the steering angle and sending that back to the simulator, and that steering angle is what's driving the vehicle. And of course, it does this very fast. So that all those camera images are going to the neural network and the steering angles are going back to the car, and the car's able to drive around a number of different test tracks. So that's a really, really fun project, and it's a great project to be able to talk with employers about. Another interesting project is vehicle and lane detection. So this is a particularly fun video by one of our students, Vivek Yadav. Vivek has some really nice debugging images in this video as well, where he shows different perspective transforms, taking a video that we shot at Udacity of driving down a highway in California, and he transforms the video so he can see the lanes at kind of what we call bird's eye view from kind of directly above the lanes. That makes it easier to identify parallel lane lines. And then he's using an advanced deep neural network to do vehicle detection. So as other cars appear on the highway, his neural network is able to stop them and drop them in boxes. So that's another really cool YouTube link to check out if you're interested. And these are the types of projects that all of our students do and that you would get to do if you join the program as well. And we hope you do. So that's most of what I wanted to talk about with regards to the program. I would love to answer some of the questions that you all sent in and questions you all might have live now. So we'll switch off of screen share, and here we are. So let's get to it.
Thank you so much for this introduction of the program. I think this should already give you guys a pretty good idea of what you can expect to see in that nanodegree. Now, as I said before, we've had some really exciting questions that you guys sent through the form. Thank you again for that. And what we're going to do, because I really want to leave enough time for you guys to ask all of your questions live. So what we're going to do is that we're going to go through 3 questions that we have pre-selected, 3 questions that you guys have put in the form in advance. And so, David, if you want, we're going to take, I'm going to ask you each question one by one, and we're going to take around 10 minutes to do that. And then once we've answered those questions, guys, feel free to put all of your questions live in the chat on YouTube, and we'll get to those questions afterwards. All right? So our first question for you, David, is, what are the course prerequisites for the self-driving car nanodegree program, and which Udacity courses can I take to prepare for the course?
Great question. The prerequisites for the program are intermediate programming ability, ideally in Python and C++, because those are the languages of the program. Python is a really important language for machine learning and deep learning, and C++ is kind of the language of the automotive industry. But if you're familiar and a pretty solid engineer in a different language, then we think you'll be able to pick up Python and C++ pretty quickly. And in addition to that, basic linear algebra, so how to multiply matrices, basic calculus, so how to take derivatives and integrals of polynomial functions, basic statistics, so things like mean, median, standard deviation, and very basic physics, so just things like forces and inertia. Those are kind of the prereqs. A lot of folks who have engineering degrees meet those prereqs already, and if you don't have an engineering degree, that's totally fine. We have, or if you feel, like you'd like to brush up on one of those areas, we have a list of courses on the on our program website. So if you go to udacity.com/drive, you'll be able to find a list of prerequisite courses or courses to take to prepare you for those prerequisites.
Exactly. Like David said, we have a lot of free courses as well. So you guys can just feel free to look into the catalog, and you'll find a lot of great resources there. Now our second question for you, David. What tools and data libraries will we use in the self-driving car nano degree?
Great question. I already alluded just a minute ago to Python and C++. Those are kind of the two languages of the program. The entire first term is in Python, and then terms 2 and 3 are primarily in C++. We have a nice introduction to C++ at the beginning of term 2, in case you're not familiar with that language. In addition to those as the programming languages, the main tools that we use in term 1 are TensorFlow and Keras for deep learning, which are two really popular frameworks for building deep neural networks, and OpenCV for computer vision. So that's term 1, the first 3 months of the program. Those are the main tools that we'll use. In terms 2 and 3, we use a C++ library called Eigen for doing a lot of matrix multiplication. And in some of our elective courses, we use, again, things like Keras for advanced deep learning. We use ROS, Robot Operating System, for the system integration module in the final month where we put it in the car. So you get exposed to a few other C++ oriented tools.
Nice. And I have a third question for you that was in the questions that were asked in advance. Someone asked, how does a typical workday look like for a self-driving engineer? And after you answer this question, again, another reminder, you guys can just leave your questions in the live chat on YouTube, and we'll get to the live questions just after this one.
Okay, cool. Yeah, so before I came to Udacity, I was an autonomous vehicle engineer at Ford Motor Company in Palo Alto. Ford is based out of Michigan in the United States, but Ford also has large research offices in Palo Alto, California, and also in Aachen, Germany. And all 3 offices, Dearborn, Michigan, Palo Alto, California, and Aachen, Germany, all work on autonomous vehicles. So my job at Ford in California was on the hardware platforms team. So this was working with different computer platforms that automotive suppliers would provide to us for potentially running Ford's self-driving car software in the vehicle. And so we would be doing things like porting Ford self-driving car code to different hardware platforms and benchmarking those platforms to see how fast they ran, how much energy they consumed, what types of other resources we wish were on those platforms so we could give that information to the suppliers. But I had colleagues who worked on things like localization, sensor fusion. I know some of my sensor fusion colleagues would rope us into being kind of test drivers for them and going out and practicing parallel parking so that we could make sure that the parallel parking code was working correctly. So there's kind of a mix of testing things live on the test track or even in the real world, and working either on a lab bench or on your computer evaluating maybe supplier code or platforms, or developing code or platforms yourself for autonomous vehicles. It's a fun job.
Nice, thank you for answering this. It's super exciting to hear about the variety of things that you guys could be doing on a day-to-day basis. And yeah, so thank you for that. As I said, we're now going to go to the live questions. And our first question is actually from Najib. Najib asked, how will the upcoming 5G system enable the self-driving car technology?
One second, let me make sure I read that to make sure I didn't misunderstand. How will the upcoming 5G system? So I actually don't quite know what Najib is referring to with 5G. I assume wireless networks. It might, so the question might have to do more with vehicle-to-vehicle communication, which is kind of an interesting branch of autonomous vehicle technology. It's also a little bit independent from self-driving cars, although usually the same types of groups that are working on autonomous vehicles are also working on vehicle-to-vehicle communication. It seems likely that autonomous vehicles will be here well before vehicle-to-vehicle communication or vehicle-to-infrastructure communication will be here, at least in large numbers, because self-driving cars can operate more or less autonomously. You can have one self-driving car on the road and it can more or less operate by itself. If you have a vehicle that is capable of vehicle-to-vehicle communication, but it's the only vehicle on the road that can do that, then the vehicle-to-vehicle communication isn't worth very much. So there's a little bit of a network problem or a chicken and egg problem inherent to vehicle-to-vehicle communication. There's a lot of exciting things you can imagine once we get enough vehicles up and running with V2V or V2I communication. You can imagine a world with no stoplights because cars are all talking to each other and figuring out how to weave through intersections without hitting anything and without stopping. You can imagine better traffic flows as cars communicate with each other about how to merge or take exits or proceed through intersections. And that may come relatively soon as fleets of cars like with Uber or Lyft or Didi or ride-sharing companies. As if one company is providing a large fleet of cars, there's a much stronger impetus for something like V2V or V2I communication, but it's probably a little further out than just standalone self-driving cars.
Thanks so much for your answer. We have the next question coming. The next question is from Franz, and Franz asked, what is the most advanced tech stack right now on the market? Is it Mobileye, Delphi, Sony, or Velodyne?
That's a really good question. So it sounds like Franz is pretty aware of all the different partnerships that are going on in the autonomous vehicle world right now. We see almost every day now different autonomous vehicle companies or companies in the automotive space forming partnerships around self-driving cars. So there are interesting partnerships going on right now with well, Intel purchased Mobileye, and then Intel, Delphi, and BMW, Bosch, Mercedes-Benz, NVIDIA. I would be on thin ice, I think, if I declared one stack to be further ahead of the other. I think that things that are pretty clear are Google or Waymo has more miles under their belt from a self-driving car perspective than anybody by a really wide margin. And so, so they have a big advantage on that front, but other companies are starting to catch up really quickly. Tesla is in an interesting position because they have so many cars on the road and they're getting so much data, even though it's not fully autonomous data. They seem to be very good at pulling that data from the cars that they have distributed to customers and then managing and using that data for training their autonomous vehicle algorithms. And a lot of times in machine learning, it's less about algorithms or hardware than it is just about having enough data. And so those are two really interesting places to be. Uber is in a really good place because of all the cars they have out on the road as well. Our partners at Mercedes-Benz have an amazing self-driving car stack. I'm partial to Ford stack because I worked there and worked on it. So I think a lot of companies are doing exciting things and have good stacks out there. One final thing just to close on is how hard it is, even working in the industry, to get a good handle on how different people's technology stacks compare to each other, because this is all very confidential and secret, and And it can sometimes even be hard when you're working in a company to get a sense of how well your software compares to other people's software, because you don't always have access to everyone else's software.
Yeah, I think you made a really, really good point there, David, so thank you for that. I have the next question from Giuseppe. Giuseppe asked us, how does Udacity incentivize its hiring partners to recruit NanoDig graduates?
Yeah, great question. So Giuseppe is referring to our hiring partners. We have now about 30 hiring partners in the Udacity Self-Driving Car Nanodegree program from all over the world, many in Europe, but also many in the United States and also in Asia. And we're about to announce in the coming weeks another big batch of hiring partners that signed up, which is terrific and we're really excited about. And the question is, why do these companies want to hire Udacity self-driving car graduates as opposed to other engineers? And there are a couple of answers to that. One is there's just a really huge shortage of talent in this area. For a long, long time, the folks who worked on self-driving cars were in the research divisions of big automotive companies, and they were relatively small groups. And that was okay because they were recruiting from a relatively limited number of university programs, or I guess it's the other way around. The fact that there were relatively small university programs supplying engineers was okay because the research divisions in these companies weren't hiring tons and tons of people. In the last few years, self-driving cars have really taken off, and the pressure to get them into production is really high, and the timelines are very compressed. And so companies are hiring like crazy to try to build out their autonomous vehicle departments. And yet the traditional kind of 5-year, 8-year PhD programs that churn out autonomous vehicle engineers aren't, they haven't ramped up to meet demand. And so what companies are looking for are other places to find engineers, and Udacity right now is, I think, the best place outside of maybe a handful of top research universities for finding people with the skill sets to work on autonomous vehicles. So our partners are really excited about hiring students out of the program, and we work very closely with them to try and figure out what they need for different positions and match them with students who are interested in working with them. So we're very hands-on from that perspective, much more so than I think a typical academic program is.
Yeah, I really like what you said, David, about being very hands-on. I think this is true for all the programs at Udacity, just being able to work on projects that are real-life projects. And I think this for hiring purposes is really, really useful. So really great for you guys. We're going to get to the next question now. The next question is from McLaren, and McLaren asks this question: how much of IMU processing and calibration as an input for poser estimation algorithms will be discussed during the course?
Great question. So McLaren, I feel like you're destined to go work for McLaren if you don't already, or maybe you're a big fan of their cars. Great name. McLaren is a Udacity hiring partner, and they're looking to build up their autonomous vehicle teams as well. You probably get that a lot. So to your question about IMU processing and calibration, so the localization we teach in the localization module of the course, which is pose estimation, where are we in the world and what direction are we headed, is based primarily on particle filters and combining sensor fusion data with high-resolution maps that the vehicle already has to figure out where you are. We don't use a lot of IMU or GPU or GPS, GNSS information, primarily because those things are really expensive. Getting high-resolution IMU and GPS systems that can do, they can do centimeter level localization for you, but they cost on the order of $50,000 to $100,000. And so most companies that are working on this are looking for more affordable ways of estimating where we are in the world, and having the map helps for a lot of other reasons. So when we combine the map that we already have with sensor fusion data, the IMU is a little bit less necessary. So that's a long answer to your question. The short answer is we don't really touch much on the IMU. It can be helpful for initializing a particle filter or other type of localization system. And IMUs are very heavily used for ADAS systems, because ADAS systems tend to not have the high resolution maps and other types of sensors that fully autonomous vehicles have. But for our purposes, IMUs don't play a key role.
Thank you so much for your answer, David. Now we have a question from Samir. And Samir asked a very relevant question, actually, something that we hear from a lot of you guys. What sort of infrastructure hardware is needed for the course? Do we get GPU credits from cloud providers?
Hi, Samir. That's a great question, very perceptive. So the hardware that we recommend you have from the course is a computer that you are comfortable developing software on already. We designed the course to support all three major operating systems, Windows, Linux, and Mac OS. I will say Linux and Mac OS users sometimes have a little bit of an easier time of it because a lot of software is developed with those operating systems in mind more so than Windows, but we support all three operating systems. In fact, in just a little bit, I'm going to do a code walkthrough on Windows. Beyond that, having a GPU for deep learning is really, really helpful. Not so much for the other modules and other months of the program, but for the deep learning modules, having a GPU platform will really accelerate your ability to train and evaluate deep neural networks. And so what we do is we partner with Amazon Web Services to provide $50 in credit for every student in the program. And we have a really clear walkthrough of how to get started with AWS and launch a GPU-enabled EC2 instance, basically a virtual server on Amazon's platform that has a GPU, and we show you how to train your deep neural networks on AWS in the cloud, and then pull them back onto your local machine for evaluation.
Thank you so much for that answer. The next question is from Rob, and Rob asked quite a long question, so bear with me, David. Rob asked, what do you think about the HERE HD Live Map Cloud-based mapping and localization for highly automated driving, where major vehicle companies support the database with entire vehicle fleets?
Yeah. So well, this is also a really great question. I'm really impressed by the kind of the depth of many of the questions here, including this one. So HERE is a mapping company that is co-owned by the big three German automotive manufacturers, Audi, Daimler, and BMW. And HERE, like several other mapping companies, uses very high resolution tools to drive around the world and map roads to very high degrees of fidelity, which is what we need for autonomous vehicles. One of the reasons building self-driving cars is so hard is that keeping these maps up to date turns out to be very expensive and very difficult. Sebastian Thrun, the founder of Udacity and the founder of the Google self-driving car project, who I work with very closely in building out this nanodegree program. Sebastian has a lot of stories about developing the Google self-driving cars in California and all the problems they would have keeping their maps up to date because the California Department of Transportation would repave the highways in the Bay Area every single night. I mean, not the whole highway every night, but parts of the highway every night. And so over the course of a few months, the entire map would become outdated because the entire highway would be repaved. And so that's a challenge for a mapping company like HERE, and there are only a few mapping companies in the world, and they're in a really good position because everyone needs their maps, but it's also a very expensive thing to keep up to date, and that's part of the reason that we only see self-driving cars in very limited geographic areas right now. The contrast to a company like HERE is a vehicle manufacturer, a ride-sharing service like Uber or like Mercedes-Benz that have vehicles all over the world, or Tesla is a great example of this. And these companies have the ability to collect data from all the different people they've sold their vehicles to, or all the different drivers driving their vehicles around, and try and compile a map together from that. Of course, that's a bigger challenge in some ways than having a fleet of your own vehicles like HERE does to go out in the world and map for you, because you're not in control of the people who are going out to collect the map data if you're Tesla. And so it's a little bit of a trade-off. Tesla is particularly interesting because they're not using LiDAR very heavily or hardly at all. And so So that's a kind of a whole separate question, LiDAR maps versus camera and radar-based maps. But right now I know HERE is in a really good position. A lot of people need their maps. There are a lot of companies like Civil Maps starting up that are trying to figure out more crowdsource-based methods of mapping. And I have no doubt that the major vehicle manufacturers are working on that too. It seems more scalable, but for the moment, HERE and similar companies are kind of the go-to solution in this space.
Thanks, super insightful to hear about all those challenges and the little like backstory about the challenges that Sebastian was facing himself. So yeah, thank you for that. I have another question for you now from Shadi. This is a question that's not so much about the program of the program. Maybe you're not going to be able to answer it, but I'm going to ask it anyway. So Shadi asked, are there any scholarship available for the course?
Yeah, great question, Shadi. The answer, unfortunately, right now is that there are not any more scholarships available. Udacity offers scholarships for a number of different programs, particularly I know in Android, for our Android programs, we have a lot of scholarships, particularly I believe for Android in Europe and the Middle East. And the reason Android, for example, has so many scholarships available is Google, in that particular case, is really, really interested in helping the world create more Android engineers. In the self-driving car world, there's a big demand for self-driving car engineers, but there's not one particular company that is thinking, you know, they just want to go out and create millions of self-driving car engineers to go work for anyone, just because it would be a good thing, you know, for them. And so we haven't been able to identify yet a company that's willing to fund large scales of large numbers of scholarships. NVIDIA, bless their soul, did sponsor a number of scholarships early on in the program, and those students have done great. But at this point, we don't have any scholarships left to give out, although we're always talking to scholarship providers to help fund those scholarships. We'd like to offer more because we know the cost is prohibitive for a number of students.
Yeah, indeed, but thanks so much for taking the time to answer that question. Now, I have a really interesting question here. This is a question that comes from Gohan, and Gohan asked, on a scale from 0 to 100, how much of the skills acquired can be applied in other industries, such as fintech, Internet of Things, etc., etc.?
That's a really good question. The scale is a little hard to know how to work with. I'm not sure whether it would be 100 or a 75 or exactly what the right number is on that scale. But so I'll answer a little more qualitatively. I apologize for ducking the quantitative angle of the question. Qualitatively, the skills used in the program, taught in the self-driving car program, are applicable to a wide number of industries, but it is important to note that the program is completely designed to help people get jobs working on autonomous vehicles or self-driving cars. That's the kind of guiding star of the course, is helping students get jobs in this particular field. However, if you think about the skills that are required to get a job in this field, things like deep learning, which you can apply in many different areas right now, including fintech, Internet of Things, robotics, flight, search engines even. We don't teach in this course some of the angles of deep learning that are less applicable to self-driving cars and more applicable to other things. So things like natural language processing, we don't teach so much because they're not so relevant to self-driving cars. But if you have a really good foundation in deep learning, which this program provides, then you're able to pick up those types of other skills pretty quickly. Some of the more robotics focused skills like sensor fusion, localization, control, those are core elements of any robot you'll work on in any field. So whether it's Internet of Things or drones or another robotic area, we had people actually who I worked with at Ford and at other places who were initially training to operate undersea vehicles or undersea robots. Submarines, basically, and they wound up working on self-driving cars for a variety of reasons. But there's a lot of overlap between different areas of robotics that you'll be prepared to work on coming out of this program. Udacity does have some other terrific programs that are a little bit less narrowly focused on self-driving cars and a little bit more broadly focused on sets of skills you can take into a variety of industries. So we have a robotics nano-degree program that teaches robotics more generally with less of a specific self-driving car focus. An artificial intelligence nano-degree program that's terrific that focuses on AI more generally. So those are different things you might be interested in if you're less interested in self-driving cars specifically, but are interested in some of these skills more broadly.
Nice. Thank you so much for that answer. We actually have another question from Shadi, and that question is, which role do internal sensors play in self-driving cars?
Internal sensors, I guess one question is, what exactly do we mean by internal sensors? One definition might be sensors that look inside the vehicle. So there are a number of companies working on things like facial detection or expression recognition. So you might have a camera actually looking inside the vehicle and trying to figure out if you're happy or sad, and or making a gesture and doing things based on that, maybe changing the music that's played. I've seen some pretty fun demos at automotive conferences of gesture-based ADAS technology. So ADAS stands for Advanced Driver Assistance System. That's the type of technology that you see in a car if you go buy a new car today. It's not fully autonomous, but it takes over some functions or is kind of advanced and helps make driving the car easier and more interesting. And internal sensors, in the definition of sensors that are looking inside the vehicle, tend to be a little more important and interesting for ADAS solutions, for cars that aren't fully self-driving but are pretty smart, because you can do things like swipe left or swipe right or make a gesture, and you're still driving, so you're paying attention to what's going on, and you know to make these gestures, and then the car can react to them. Whereas in a fully self-driving car, you might want to just go to sleep and not have the car pay too much attention to you. There's some interesting work going on in this area, but I wouldn't say it's necessarily super critical to fully autonomous vehicles. It's more of kind of like an interesting project to see what comes.
Nice. And I guess looking at the time that this is going to be our last question for you, David, that we're going to answer live. That doesn't mean that we can't answer more questions, guys. And after David answers the last question, I'll give you a little bit more details on how you can stay connected and how you can ask more questions. So no worries. But here we go for the last question of this webinar. This is a question that comes from Ben Cato. And Ben Cato asks, there are no big car companies in my country. Do you think self-driving car engineering will be in demand somewhere else as well?
Yeah, great question. So autonomous vehicle development is definitely something that is happening in a number of geographic areas, but not yet everywhere in the world. It's also a field that hasn't so far supported a lot of remote work. But we can talk a little bit about the areas in the world where autonomous vehicle development is happening, and then places where it might expand in the future, and some of the things you might think about if you're living in an area where there isn't autonomous vehicle development, but you'd like to work on autonomous vehicles. So the big places that focus on autonomous vehicles right now are Germany, all over the country, because Germany has such a strong automotive industry. As well as in the United States, Detroit, which is the kind of the heart of the automotive industry in the US, the Bay Area, which is the heart of the technology industry in the US, and Pittsburgh, actually, because Pittsburgh has such a strong robotics program coming out of Carnegie Mellon University that Uber and other companies have taken advantage of. Outside of these areas, Japan is also doing a fair amount of autonomous vehicle work because of the strength of the Japanese car industry, and we're seeing demand for autonomous vehicle engineers grow in some markets like China and India, and the UK, places that have maybe not quite as strong automotive industries as Germany, US, Japan, but still have vibrant automotive industries and do a lot of work in these areas. And as companies search for talent in a lot of areas, or search for talent that's hard to find right now in autonomous vehicles, they're willing to open up offices, in almost anywhere they can find a good concentration of talent. Uber, for instance, just opened up a Toronto office in Canada, largely because there's a really great academic group in Toronto that was excited about Uber. So those are some of the areas in the world where a lot of autonomous vehicle development work is going on right now. Other places in Europe too that have automotive suppliers. We were just talking yesterday with an Italian automotive supplier who's looking for autonomous vehicle engineers. If you live in another area that does not have autonomous vehicle engineers, one of the upsides of the demand for autonomous vehicle engineers, if you're open to moving, is a lot of companies are willing to support relocating an engineer who has skills in these areas, because it's so hard to find people who have skills in these areas and who are willing to work for your company. And so we've talked to a number of hiring managers who've said, look, I just want to find the best fit for this role anywhere in the world, and we will deal with getting them from wherever they are to wherever we are, because demand for talent in this industry is just so high. Now, if you live in a remote island in the middle of the ocean and you definitely don't want to leave that island because that sounds like a great life, then it may be hard to work on autonomous vehicles. But I think in a lot of places, the autonomous vehicle industry is growing, and in places where it's not yet growing, if you're interested in relocating to areas where it is growing, there's a lot of opportunity for that.
Thank you so much for this last answer, David. I think that I can talk for everyone when I say that this was a really, really exciting and really insightful webinar. I think it just puts into perspective how relevant the curriculum is in today's economy, and how many job opportunities there are there for self-driving car engineers. Thank you so much for joining us all the way from Virginia. It was an honor to have you, and I'm pretty sure that all of our European students are really excited. For you guys, thank you so much for all the questions that you have submitted in advance. Thank you so much for joining tonight. We're really excited to be doing more of those webinars, and there are actually a couple of ways that you can stay in touch with us. If you have questions that haven't been answered in the webinar, or if you have questions that are very specific to the European market, you can send those questions to the address that we are going to write in the live chat. The address is de/support@udacity.com. But don't worry, we will also put this in the description of the video. And another thing that I wanted to announce today is that we have just opened a Facebook group for all of our students in Europe, so that you guys can find each other and you can continue to discuss all of those topics. And we would be really, really happy to see you in that Facebook group, to see you guys connect with each other as well. Like with the email address, we will just put all of that in the description of the video. So you don't have to worry, you will have all the information you need, and we will also send you, all of you who registered, a follow-up email with all of that information in there as well. Thank you so much for joining. Thank you once again, David. And I'm just wishing everyone a great evening.
You are welcome. Bye-bye.
Bye, everyone.